So guys, you have to share your mail IDs so that I would like to send you the all recording into through Canvas account. Okay. So this module, which is purely related to machine learning, right? Okay, fine. So do you know anything about machine learning, Sweta?
Yes. Oh,
Sweta, or else Samir, can you please tell me what exactly you know about machine learning?
actually, I took some machine learning classes a couple of years ago,
Okay.
but I forgot a lot of it.
Okay.
I know about the basic I was familiar at the time. I was familiar about the basic algorithms of machine learning, like linear regression, logistic regression,
Okay.
support vector machines, and those decision tree, and using decision tree to do
Yeah.
random forest and those things. I did them last few years ago, but I forgot a lot of it, and I also familiar about the deep learning and uh, using deep learning for
Mhm.
and for the email the one what's called the neural networks.
That's fine. That's fine, Samir. That's fine. These are the things you have some basic
Uh,
knowledge,
yeah,
and you have some kind of previous intuition. And
yeah.
my question is, what exactly the machine learning? What do you
Huh?
know? What exactly the machine learning? That's what I'm trying to asking the question. Okay.
Oh, the definition of machine
Yes,
learning.
the definition of the machine learning. Do you know anything about the definition of the machine learning?
The definition is machine learning is using mathematical and other models for a computer to learn from itself or from a data.
Okay.
That's what I know.
Okay, so with help of some kind of mathematical and mathematical functions, it can go
Uh,
for creating the model, right? It can
yeah,
create the model, right? Okay,
yeah, model that
that's
makes a computer.
that makes sense. Yeah.
Yeah,
Do you know
yeah.
anything about machine learning, Sweta?
Huh?
Sweta, I'm talking to Sweta.
Yes,
Straight
sir.
up. Oh,
Yes.
sorry.
In machine learning, uh,
Hmm.
we can operate some mathematical things like a number of questions, or we can do minimum or maximum values. We can means we can learn their deviation, what is mean by deviation, what is mean by mean, what is mean by mean value, what is mean by range value, what is mean by what is the percentage of any object, means if uh, suppose there is a number of heart disease patient, and we have to find out how it is um, heart heart disease, or we and or which are not has been affected by the heart disease. uh, Such type of things we can find out from this, and on the basis of this we can make a we can make a model, mm, means
Yeah,
we
yeah,
can
cool,
say,
cool, cool. I
yeah.
guess, yeah, you guys are having some kind of intuition about machine learning. Okay, that means where we can use it and the stuff you already know it. Okay, now this time I would like to talk about the what exactly the machine learning I want to try to tell you actually. Okay, see, machine learning means you just think, okay, there could be some kind of software, okay, or else there could be some kind of hardware. Okay, just imagine this is one particular software, or else it might be some kind of software. Okay, see what it can do actually, it can be learn itself. What it will do, it can be learn itself. How it can learn itself? So you have some kind of historical data. So here we have some kind of historical data. So make sure that this data, it was purely in a structural format. Okay, structural data. You have some kind of structural data. With this particular structural data, the software, the hardware, it can be learns itself and after it was learned something, I mean, what exactly the patterns on inside of that particular data, then what it will do, it will creating some kind of model actually, okay, mathematical model. This is exactly the machine learning definition. Clear or not? See,
Yes.
by the time if you're getting any kind of some kind of new data, then it will give you some kind of corresponding result actually. Okay, this is exactly the machine learning. So I just want to compare the machine learning algorithm and the traditional program. Okay, for more understanding of the definition of the machine learning. Clear? See, I just want to be a give. I just want to write a program for addition of two numbers. Just imagine yourself. Okay, write a program addition of two numbers. Okay, then what you can do actually in traditional concepts, in traditional concept, so it needs that addition of two numbers. In the sense, you should require the two inputs, right? X1 and X2. These are my inputs. These are my inputs, right? These inputs, I can create some kind of a program or algorithm, X1 plus X2, and it was generating the result. Is it clear or not? This is usually the traditional program can be work. This is the program you should write. This program, it may be Python program, it may be C++ program, it may be, okay, Java program, whatever it is. So you might be using any one of the programming language for addition of two numbers. That logic, it will take the x1 and x2 and it was giving some kind of result. For example, if you're giving some new data, even though you're getting the output for that, yes or no? Now, I want to tell you the same thing if I do how the machine learning algorithm and how the machine learning will do that. See, here are some kind of historical data. Okay, here I have the some kind of historical data. The historical data is here x1 and x2 and corresponding output actually. Okay, and here for example 1, 5, 6 and 7, 5, it could be the 12 and 10 and 12 or 11, it could be the 21, right? So just imagine this is my historical data. Okay, so this is the data whatever you have it, and with help of this data what I can do actually, I'm just giving that any one of the ML algorithm. Okay, ML means machine learning algorithm. So the machine learning algorithm, what it will do, it was generating the some model. The model is addition model. It was generating the some kind of program, or else program means or model, whatever it is. Okay, see here, if I'm giving any kind of some new inputs, okay, some new inputs, for example 5 and 10, it was generating the output for that. Is it clear?
Yes.
So now you are getting now you're getting the difference between the traditional program and machine learning program. So this is the algorithm. This algorithm could be predefined algorithm. This algorithm is what? It's a predefined algorithm. This predefined algorithm, we would like to write either using the Java program, either we might be using the Python program, whatever it is. Okay. So whatever the historical data you have it, this historical data, if you are providing to the any one of the machine learning algorithm, the machine learning algorithm, it could be go for creating the some model. That model we can call it as the program or new program. To this particular new program, if I'm giving any kind of some new inputs, then I would like to get the some kind of outputs actually. Okay, but in case of traditional program, what we'll do actually for writing addition of two programs, so you might have some kind of logic. That logic you're going to be building with help of any one of the programming language. Then that logic, if you're giving some new data, then you will be getting output actually. Okay, so but in case of machine learning algorithm, you don't need to define your own program. You just have some kind of machine learning algorithm. To that particular machine learning algorithm, you can provide the historical data. It was creating the patterns based upon that particular data. With the help of that pattern, you can do some kind of new results actually. Okay, so unknown information. You can able to go for finding the some kind of unknown information. Okay. Any question regarding about the traditional program and the machine learning program?
Anil, I was a little late. Just
Yeah.
saw your message. So can you repeat one more time, please?
Yeah. So nothing I'm explaining here. So the definition of the machine learning I'm trying to be sharing here. Okay. So here my point is, what is machine learning? So Arvindo, do you know anything about machine learning? Can you please tell me what exactly the machine learning?
I mean, it's just an intelligent way of interpreting data.
Okay. Yeah. That is also correct. So people can give that their own answers actually. Okay. But you might have some kind of standard definition, right? Okay. The standard definition is the machine learning, it can be learns itself. That's it. The machine or the software, the program, it can be learns itself with help of some kind of historical data. That is the standard definition of the machine learning. Okay. For understanding this one, so you might have some kind of, you need to know some kind of difference between the traditional program and you should know the and machine learning actually. Okay, machine learning program. See, here I have some kind of traditional program, right? So the traditional program is, here my question is, or my problem statement is a factorial of a number. I would like to go for factorial of a number. So if I'm giving any kind of new number, I would like to give the result of the factorial of number. By the time, what you can do actually, you are going to be writing some kind of logic. You're going to be writing some kind of logic with the help of the Python or else whatever the programming, whichever the programming language you're comfortable, that logic we are going to be implementing. Is it right or not? So to this particular logic, if I'm giving the any number, okay, then I'm getting the result could be 10 factorial actually. Okay, if I'm giving some kind of new data, then 5 factorial means what? It's a 120, right? It's a 120, right? Okay, so this is the way you are writing the program in a traditional manner. Okay, but the same thing, how the machine learning program can do, that's what my intuition here. Okay, see, you have some kind of historical data. You have some kind of historical error. The problem statement can be anything actually. You should have some kind of historical data. Clear? The historical data is here. For example, find, and it could be the 120, and it could be the 4, and it could be the 4. What is the value? 3 into 1 into 2 into 3 into 4. What is that? 3 into 4 into 1, 2,
24.
24. Yes, 24. And for example, you have some kind of historical data, something like this. Okay, this is my historical data. This historical data you have to be considered in CSV format or Excel format or text format, whatever it is. Okay, you have some kind of historical data about your n and corresponding factorial of each and every number. Okay, so you have some kind of already some machine learning algorithms. So the different kind of machine learning algorithms are there. Based upon this particular data set, you should use those particular machine learning algorithm. So once if you are using the machine learning algorithm, it was generating the program. That program only we are calling it a model. Okay, ML model actually, or else you can call it as a program. So this is the model which is created by machine learning algorithm. To this particular model, if I am giving any new data, if I'm giving some kind of new data, then I'm going to be getting the new result actually. Okay, if I'm giving the result, for example, if I'm giving the 10, whatever the number of whatever the factorial for the number, whatever the factorial for 10, that result we are going to be getting actually. Clear? So here in this situation, did you written any kind of factorial of a number? Did you created any logic with your own? No, you're not creating any kind of logic. You have some kind of predefined machine learning algorithm is there. To that particular machine learning algorithm, you're just giving historical data. That algorithm, it was learning with historical data and it was creating the model. That model we are going to be using in your future predictions, or else in artificial intelligence, or wherever you want to use that model, we can use it actually. Clear?
Clear.
Arvindo, Samir, and Ahmad.
Clear.
Ahmad, is it your first class, or else you're attending the Python sessions as well?
I'm attending Python session as well, but for machine learning, this is my first class.
Okay, so do you get that difference between the machine learning algorithm and traditional program?
I actually joined now. I didn't.
Okay, so what you can do actually, I explained multiple times regarding about
It's okay. You can continue. Like I have basic ideas. So.
yeah. Difference between the traditional program and machine learning algorithm. Okay, I already created the recording, and I would like to share the recording as well. Okay, so you can go ahead actually. Okay, right. So you guys are understood what exactly the machine learning algorithm, right? Now, what are the machine learning algorithms are there, and where we can use it first of all? The second point is that where we are using, where we are using, tell me, anybody. See, if you wanna become like a data scientist, okay, without machine learning we can't. Okay, if you wanna become like a data analyst, you required okay, machine learning algorithm concepts. And if you want to become like a AI engineer, you require the machine learning algorithm. So applications are different, but these are the fields we are using. These are the fields. Okay, in this particular fields, we're going to be using the machine learning actually. Okay, even in banking, those are domains actually. These are technologies: data science, data analytics, business analytics, business intelligence. Okay, and these are all the things are, it's a technologies. In this particular technologies, the machine learning could be the backbone. Okay, now, so in which domains we are going to be using the machine learning? I think wherever data science we are using, of course we are going to be using the machine learning in finance, in sales, and banking and marketing. Okay, and financial analysis purpose, and and healthcare analytics, and wherever we are going to be using the data analytics and data science and machine learning and artificial intelligence. So definitely we are going to be using the machine learning algorithm. So plenty of applications we have it. And you know what, machine learning is it's already the importance of the machine learning today, right? Chatbot. So the chatbot, and I mean chatbot in the sense chat GPA, people who created chat GPA, OpenAI people, and Google Analytics, and even the backend of algorithms of the Google. It's a pretty thing. It's a machine learning algorithms only we are using in a backend. Even in a Facebook and Twitter, every high-end applications, the backend we are going to be using the machine learning algorithms only. Clear?
Clear.
Okay. Now, what are the types of machine learning algorithms we have it? Okay. What are the types of machine learning algorithms? You know it, first of all. So there are 4 type of machine learning algorithms are there. The first one is the supervised machine learning algorithm. Okay, supervised machine learning algorithm. The second one is unsupervised machine learning algorithm, and third one is the semi-predefined machine learning algorithm. The last but not least, it was the reinforcement machine learning algorithm. Okay, so you might be thinking, what exactly the supervised machine learning algorithm, what exactly the unsupervised machine learning algorithm, what could be the semi-predefined, what could be the reinforcement. Okay, see now, so supervised machine learning algorithm, in the sense, you just try to be go for understand here. I already told you, right? Machine learning algorithm, it works with help of the some kind of historical data, and make sure that that historical data, it could be structural format, right? So whatever the historical data we have it, so then if we have historical data, then it might be supervised, it might be semi-supervised, it might be unsupervised. Okay, so these are the three type of algorithms can works with help of the some historical data. But when it comes to the reinforcement, so no data. If you don't have a data, even though the machine learning algorithm can be getting some kind of pattern, that the type of algorithm is, it's a reinforcement algorithm. Now you are getting the difference between one by one. So first try to be go for a reinforcement machine learning algorithm. Reinforcement machine learning algorithm, in the sense, the algorithm, it can learn itself without any historical data. That exactly the reinforcement machine learning algorithm. Clear or not?
Yes, clear.
you
Um,
might you might be
For
thinking,
yeah, but
example, for
yeah,
example,
sorry.
uh, for example, means without using historical data, how can we use information?
Yes, just try to be understand. You are the by the time of born, you don't know anything, right? Okay. Okay. So here we have reinforcement, and so here you have some kind of agent. Okay. See, so you did one particular task actually. Okay, so this is the task which we are done by the reinforcement machine learning algorithm. The agent will look that whether it is a correct result or wrong results. Okay, if it is a correct result, you'll be getting some kind of rewards. It may be positive rewards. Okay, if you're getting the positive rewards, that means your task is done. If you're getting the negative rewards, then the task is not correct actually. So with help of this thing, which was creating itself some new data. Okay, so based upon the task, what the reinforcement is doing, so it may be trial and error actually. So if you're getting the true, if you're getting the correct, then it was positive rewards. If you're getting the so no, it could be negative rewards. Okay, like sudoku game. Okay, and chess games, behind these things could be, it was a reinforcement only. Okay, yep. So but
one question I had is, like for stats, you had this statology website, right? Is there a, for the theory part, is there for machine learning also you recommend some website to read through all these
sorry,
algorithm types? I mean, is there a website to read through the theoretical aspects of these machine learning algorithms?
you don't worry about it. I was creating the documents. Okay, and I would like to share with you. The reason is that for everything, no some specific website which is not available. Okay, so I'm creating that documents for each and everything. I would like to share.
Okay.
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 Yep. So whatever the session I'm explaining for that day I would like to share, corresponding documents.
Sounds good. Okay.
Okay. So just for sake of understanding, I would like to, even I'm creating some website for which the name is TechSkill. So blogs I'm creating. So for example, data science project. Okay. So this way I'm creating the document with my own, like it can help you for documentation purpose. Okay, so each and everything, whatever concepts explaining that, so these documents will help you. So these documents I can share with you to my students in my Canvas playlist. Okay,
Very good.
yeah. So but uh, whatever I did it, then that corresponding documents only I can share with you. Okay, so now let's go for understanding the semi-predefined. Semi-predefined in the sense combination of the supervised and unsupervised. But first we'll try to go for understanding the supervised. So I already told you, right? We have we have historical data. So when we have some kind of historical data, the data, it could be having the two kind of things, two kind of variables. Okay, the variables are it could be response variables or predictor variables. Okay, so x1, x2, and for example y. Let me consider this x1, x2, those variables we are calling it say features variables or else predictors variables or else independent variables. Different kind of textbooks, they're following different kind of names actually. Okay, just try to be followed. Independent variables, features variables, predictor variables. When it comes to the y, this is the y or else input variables. Simply you can say that it's a input variables. Okay, and coming to the y we can call it the output variable or else dependent variable, dependent variables or else response variable. Okay, so y indicating that it's a y indicating that's your output, and the name it could be dependent or else response variable. And the y, the dependent variable, it might be depending on the x1, it might be depending on the x2. For example, 1, 2, 3, and 5, 6. It could be 11, right? Here 3, it is depending on the 2, and the 3 which is depending on the 1, but 1 is not depending on the 2 and 2 is not depending on the 1, right? Okay, so meanwhile the 11 which is depending on the 6, the 11 which is depending on the 5 actually. Okay, so here whatever the variable, that it could be dependent variable, which means that the dependent variable which is depending on the independent variables. Okay, so this is the way the data set it can be segregating into two type of variables. One is the dependent variable, second one is the independent variable. You have only one dependent variable, but you may have the multiple independent variables. Clear? So the data, the historical data, if we have this particular dependent variable, that variable we are calling it a label variable, a label data. Okay, so that kind of data we are calling it a label data. Okay, see the historical data, if we have a label data or output variable or else dependent variable or else response variable, we would like to go for the supervised machine learning algorithm. We would like to go for the supervised machine learning algorithm. I hope you clear when we can use the supervised machine learning algorithm. Any questions? So supervised machine learning algorithm can be work when the historical data, when we have the dependent variable, then we can choose the supervised machine learning algorithm. Clear? So you don't have any kind of output variable. So that situation you can go ahead. This is your historical data. Okay, so with help of this historical data, so it could be like x1, it could be x2, and it could be x3. So this is the data you have it. You don't know what exactly this data, and but even if you don't have any kind of label variable or label data, then that situation we would like to use the unsupervised machine learning algorithm. Unsupervised machine learning algorithm. Clear? Unsupervised machine learning algorithm can be takes place when we don't have the response variable or dependent variable, and which means that no label data. When we don't have the label data, then that situation we can able to go for choose the unsupervised machine learning algorithm. Clear?
Clear.
That's pretty good. Now you might be thinking, again, in case of supervised machine learning algorithm, we have the two type of. Yes, tell
Excuse
me.
me, sir.
Yes, tell me.
In unsupervised machine learning, means we don't get the output like that.
If we don't have output variable, okay, what you want to do, if you don't know, you have some just data, you have it from that one, you would like to go for creating some kind of clusters that is exactly done by the supervised machine learning algorithm. I'll just give you some example. Okay, so the country there are 150 crore of population is there in India, right? So out of that one, you have some kind of data about each and every person. Okay, so based upon that one, you would like to creating some kind of clusters. Okay, whether the guy is good behavior or bad behavior, or else whether his guy is having so pattern, whether it is a good or bad, or else medium or whatever it is. Okay, you are going to be creating some kind of cluster, but you don't know what exactly is right, whether the guy is good or bad, you don't know, right? Based upon that data, we are going to be creating some kind of clusters, groups, that exactly unsupervised machine learning algorithm is there. You don't worry about these things. Again, I can explain these things in upcoming sessions. Once I done all the supervised machine learning algorithm is done, then I can go ahead the unsupervised machine learning algorithm. By the time, I would like to talk about the hierarchical clustering, okay, and k-means clustering, DB scan clustering, and PCA, principal component analysis. This all things I can explain you in unsupervised machine learning algorithm. Okay, just you can try to be understand, when we don't have some kind of labeled data, what you want to do with help of that data. If you don't know, you have some kind just raw data is there, and with help of that one, you're going to be creating some kind of clusters or groups that we can do with help of the unsupervised machine learning algorithm, right? Okay, now I would like to talk about supervised machine learning algorithm. In this particular supervised machine learning algorithm, we have the two type of machine learning algorithms are there. The first one is the regression based supervised machine learning algorithm, and classification supervised machine learning algorithm. So I already told you, right? Here we have some kind of output variable. Okay, here the output variable, it could be a number, a continuous. Okay, it could be a continuous or it could be a number data. Then you would like to go for using the regression, simple thing actually. So I would like to go for predicting the car price. So car price, in the sense, the output variable, it was number, right? Okay, and I would like to go for finding the height of the person, the average height of the person in one specific country. Okay, that particular situation, height in the sense, it could be some kind of number, right? Okay, if the output variable, it could be a number or continuous data, then we would like to go for using the regression. And coming to the classification, categorical. Okay, categorical, right? For example, based upon the data, you would like to give that movie rating or restaurant rating. Okay, or else and so whether mail is spam mail or not, different kind of problem statement, which is having some kind of categorization. Okay, that situation, classification will be the good place to work on it. Any questions regarding about this one? Shalini, Sweta, Arvindo, and Ahmad and Samir, what are the different kind of machine learning algorithms, and supervised, unsupervised, semi predefined, semi supervised. It's not semi predefined, spelling is wrong. Semi supervised, but actually this type of algorithm which is not there, just sake of understanding. So that means this type of algorithm, first of all, it's not there, it's my own assumption. Okay, don't worry about, don't confuse yourself. You just try to be understand only three type of machine learning algorithms: supervised, unsupervised, reinforcement. When we have historical data, it might be supervised, unsupervised. If you don't have historical data, make sure that you should go for the reinforcement. In interview questions, in interview you might be getting this kind of question actually. Okay, see, I don't have a data, but I want to build the meaningful machine learning algorithm, and I want to create the machine learning model. Is it possible? Most of the people can say that no, actually. Okay, it was wrong at. Even if you don't have a data, there could be a probability you can creating the model with the help of the reinforcement machine learning algorithm. You have to say yes, the appropriate algorithm, it could be reinforcement. Okay, now you have some kind of historical data, but I don't have the label data. You might be thinking, what is label data? Label data in the sense, most of the people can thinking like training data and testing data. Don't training and don't testing actually. Label in the sense you don't have some kind of output variable, dependent variable, response variable. If you don't have a category or if you don't have a response variable, then that situation, the data what we have it, with the help of that one, we are going to be creating some kind of patterns or groups or clusters that we are calling it say unsupervised machine learning algorithm. Okay. And supervised machine learning algorithm in the sense you have some kind of historical data. The historical data, you have a labeled data. Labeled data in the sense you have a dependent variable, you have a dependent variable, response variable, or output variable. That situation we can choose the supervised machine learning algorithm. Again, in supervised machine learning algorithm, we have a two type of supervised machine learning algorithms are there. It could be regression based learning machine learning supervised machine learning algorithm and classification based supervised machine learning algorithm. Regression in the sense the category, the data type of the output variable, it was the continuous, a number, then it could be regression. The data type of the response variable or dependent variable, it was the categorical data, then it could be a classification a problem, right? Then you should use the classification machine learning algorithm. Now, so in regression, we have a lot of machine learning algorithms are there. In the meanwhile, you have a lot of classification machine learning algorithms are there. Let's list those things actually. The first one is the SLM. SLM means simple linear regression. Okay, simple linear regression. MLR means multiple linear regression and polynomial linear regression and ridge regression and lasso regression and decision tree regression and random forest regression, no, and many more actually. Okay, we have a lot of regression based algorithms are there. So simple linear regression, multiple linear regression, polynomial linear regression, ridge regression, lasso regression, decision tree regression, random forest regression, and support vector regression, and KNN regression. Lot of regression concepts we have it. Okay, but most of the time we are going to be using the multiple linear regression, random forest regression, decision regression, ridge regression, lasso regression only. Okay. Now, coming to the classification, we have the logistic regression. LR means here logistic, not linear, logistic regression, and support vector mission, and KNN K nearest neighbors, okay, and decision tree classifier, and boosting and bagging techniques. It could be like a random forest and XGBoost and gradient descent XGBoost, and lot of things we have it in classification again. Okay, now coming to the unsupervised machine learning algorithm, you have the k-means clustering, hierarchical clustering, okay, and DB scan and PCA. These are all part of the unsupervised machine learning algorithm. Okay, when we have this type of algorithms, then you are good in machine learning actually, at least these things. Okay, so these sessions, what I can do actually, I would like to go for explaining. I would like to start with the simple linear regression, multiple linear regression, and by one I can finish it all algorithms with theoretically and mathematical formulas and with examples with a program as well, Python program. Okay, and at least one program or one project in such a way we will finish it each and every machine learning algorithm. Any questions for this particular session?
What kind of tools do we need to create this kind of models and run this kind of models?
I already told you, right? So it totally depends upon, okay, if you have historical data, it might be probably supervised and unsupervised. In historical data, if we have a output variable, then we can go for the supervised. If we have output variable, if we have continuous data type, then it could be regression. If it is the categorical type of,
Talking about what tools are you going to use? Like,
okay,
are you going to
tools,
use
okay, fine.
pandas, numpy?
Okay. So those are, tools in the sense, those are libraries. Whatever you're saying, that could be the
Libraries.
okay. But usually in real time, and companies are using the Python programming language, or else R language, SPSS, and SAS. These are the tools, and stata something is there. Okay, like we have a lot of tools. We have it. These are all tools, are the statistical tools. Okay, but I would like to go for the Python and R. Okay, and if some situation I can use SPSS also, but most of the time 95% to 100% I can go for using the Python only, and some situations I can use the R language also, just sake of understanding how the R language is working. Okay, but I'm not teaching that variables and other stuff in R language. If you know the Python language, it's fair enough to understanding the R yourself. Okay. So the tools, the libraries, what we are using in when you're working with machine learning, of course, we have to know about NumPy. Make sure that if you are working with machine learning algorithm, the data, it should be NumPy format. Okay, then only the machine learning algorithm can be works. Remember this thing. Okay, if you have some kind of historical data, you have, so that historical data, if it is in the not NumPy format, then the machine learning algorithm, it won't work in Python programming language. It's just remember that word. Okay, before we applying the machine learning algorithm, make sure that it could be NumPy format, so that we're going to be using the NumPy, and we are going to be using the pandas, and we are going to be using the matplotlib. And why we are going to be using the matplotlib and NumPy? These two are the data processing libraries. Okay, before we do any kind of machine learning algorithm, and as I said, when you're working with data science, okay, projects, make sure that you need to figure out, problem statement, right? After that one, we need to prepare the data, and we have to collect the data. After that one, we would like to go for visualize the data, then we would like to go for using the machine learning model, right? And the model, you have to go for evaluate whether it is working properly or not, then we would like to go for the deployment. After your deployment, then it will be go for the maintenance. This is actually data science life cycle. Okay, so this problem statement, this is the problem statement. The problem statement in the sense your business problem. So what exactly the client needs actually. So based upon that one, you need the data, right? In this step, we are going to be collecting the data. After you collecting the data, we should go for prepare the data. Okay, for collection and preparation, we would like to go for using the pandas and NumPy and bootstrap, data scrapping techniques we are going to be using in data acquisition and data preparation. For data visualization, if I'm using the Python programming language, matplotlib and Seaborn, okay, and these are the mostly
Where does
used.
Spark, PySpark fit into this, right? Data break Spark, Can you not do data acquisition using Spark, PySpark? And
That could be big data. That it could be the big data engineers who will do actually. Okay, data engineers. Actually, this is the part it will take care by the data engineers. Okay. So data science live project, which is not involving only one guy. So most of the time, our work is from here only. Most of the people, they're working on this area. This area, data engineers can work. Okay, maybe the data engineers, they're from AWS data engineers or big data engineers, okay, or else Azure data engineers, or whatever it is, or SQL data engineers, whatever it is. So the data engineers, the primary work is that they need to be go for collecting and processing on, right? But if in case of Python data science, okay, so data preparation, like if is there any kind of missing data, or else the data it is not in a proper format, then we are going to be using the NumPy, okay, and we are going to be using the pandas. Okay, in case of data visualization techniques in Python programming language, we are going to be using the libraries are matplotlib and cworm. Okay, in case of model building, we are going to be, if you are using the machine learning algorithms, then it could be SQL, scikit-learn, okay, or else PyTorch. If it is the deep learning algorithms, PyTorch, TensorFlow, okay, and no, PyTorch, TensorFlow, Keras, other stuff. Actually, it's a model evolution. Model evolution in the sense there could be some kind of matrices, and that all matrices it can be met or not, and based upon that particular evolution, whether model is good or bad. If the model is good, then it could be deployment. In case of deployment, people are using the AWS, Azure, and other stuff. And then you already know that once the model is deployed, then it will be under maintenance. Okay, so try to go for understanding. Data science is different field. Okay, data engineers is different field. Big version, both are. Okay, so the data engineers, which is involving that data collection part, data streaming part, right? So like if it is the big data platform, if guys are using, they know that Spark and Scala and Hive, Peg, and NoSQL. So if it is the Azure Databricks and Data Lake, or else other stuff we might have it in case of data engineers. In case of AWS also, the people working on data engineer, okay. And but our work is not data engineer role. Our work is that data science. Data science means you don't need the entire data. Okay, you don't need the population data. You just need some kind of sample data. Okay, even if you have a 30 records are there, we are going to be giving the 95% of accurate model actually. Okay, how we can do with the help of the data science and machine learning model. So by the time we have to start with the preparation, data exploration, data visualization, data modeling, data model evolution, model deployment, and model maintenance. This entire circle, it could be data science project life cycle. Clear? Arvindo, is
In
it
this,
clear?
so in this class, you are going to be covering data preparation, exploration, visualization, and
Yes.
model building also.
Yes, exactly.
Okay.
Yep. This is for today's session actually. Okay. So by tomorrow, and I can share you this document. So what exactly this document? Okay, so it could be, this is the document I can share with you, and we can go ahead and
Okay, very good.
okay, bye. Take care. See you, Samir, Ahmad, and Arvindo, and
Thank you.
Sweta. Yeah.